All right, class, welcome to Lab 10 for week 10. The first thing that we're going to go over is how to go about graphing rational equations. There are two types of rational equations that you'll see. The first kind are when we're dealing with, you have a rational expression, but then you also have a constant at the end. We're going to handle that one differently than we would just the standard rational equation like part B. So if we look at part 1, or question 1, part A, we actually will work these equations just like we would any other polynomial equation. We look and see, okay, what's going to shift it up and down, what's going to shift it left, right, and of course, what's going to flip it over the x-axis. So we're going to go about it standard, right? So we know from previous problems, right, the number at the end, right, he's going to shift us down 3 units. That negative that you have in the front there, he is actually going to flip over the x-axis. And of course, the number inside of our problem, well, he's going to go in the opposite direction. So if he is plus 2, technically we're going to go to the negative 2. So we'll go left 2 or negative 2. So we're going to go left 2, down 3. So left 2, down 3 puts me right about here, right? That's actually my point of intersection of my horizontal and my vertical asymptotes. So I'm going to draw a vertical line through it where x is negative 2. Right, so I have a vertical asymptote at x equals negative 2. Right, and then I'll also draw my horizontal through it where I know y equals negative 3. Now, to figure out exactly what quadrant my graph is going to go in, well, I need to actually pull some points from the left and from the right side and plug them in. So what I'll do is from my vertical asymptote, I'll choose a number to the left. So I'll choose the number directly to the left. I'll choose negative 3. So I will plug in negative 3 into my equation. Let's see, I get negative 1 over negative 3 plus 2 is also a negative 1. So negative 1 over negative 1 minus 3, that's 1 minus 3, that's a negative 2. So at negative 3, I have negative 2. So at negative 3, I have negative 2. So I have a point right there. Okay, so I know that I'm going to have a graph on this side of my vertical asymptote. So now I'm going to choose a point to the right. So I'm going to choose negative 1. So I will go and I will plug in negative 1. So I'll get 1 over negative 1 plus 2 minus 3. Do the math. I get negative 1 over a positive 1. So that's negative 1 minus 3. That gives me a negative 4. So I know I have a point at negative 1, 4. So negative 1, 4. He's a point on my graph. So again, I know where he's located. I'm going to take and draw my lines, and I'm done. All right, for problems like B, where I'm just given my rational expression, I'm going to work them exactly like I did in previous weeks. Okay, so I know my vertical asymptote is controlled by my denominator. So I'm going to do x plus 2 equals 0. I solve it and I get x equals negative 2. So I will have a line at negative 2. All right, then I will take, and I know to find my horizontal, I actually look at the x over x. Remember, if they are the same, then we can use the numbers in front, which are 1. So I get 1 over 1, which is 1. So I have a horizontal asymptote at y equals 1. So I will draw my line. Now again, I plug a point to the left of my negative 2 and I plug a point to the right of my negative 2 to figure out what quadrant exactly it's going to fall in. So if I were to plug in, let's see if that's negative 3. I'll choose negative 3 minus 1 over negative 3 plus 2, I end up getting negative 4 over negative 1, which is 4. So I have a point at 1 at negative 3 positive 4. So negative 3, 1, 2, 3, 4. So I have a point there, so I know it's in that quadrant. And of course, I know it's going to be the quadrant opposite of that I am going to take. I'm going to draw my line. And then I also know I'm going to have a point at what? Negative 1/2. So I know it's going to be at 0. Negative 1/2 is going to end up being my y-intercept. So I'm going to put a point 0, negative 1/2. If I were to solve x minus 1, I would get x equals 1. I got a point there. So I'm going to then take and draw my lines. So we use the parts to help us find all of the pieces that we need for our graph for part B. So I like problems like A. A is nice and simple. I know how to do the flips. I know how to do the shifts, up, down, left, right. And then I just, again, choose a point from the left and the right of the vertical asymptote, and you just figure out what quadrant it's located in. All right, for C. Of course, I take a look at it and I notice it's x minus 1 over x squared minus 1. I'm going to have to factor this problem before I can do anything else. So I have to factor the denominator. I have x minus 1 in the numerator. Factor the denominator, and it's a difference of squares, so x minus 1, x plus 1. These two cancel out, and I'm left with 1 over x plus 1. Now remember, I have to know all the parts. So I am going to first find the vertical asymptote, which is my denominator. So I do x plus 1 equals 0. So I know it's at x equals negative 1. Draw my line. My horizontal asymptote, I'm going to take the x over x squared, right? Or you could take it and do, there is no x on the top and an x on the bottom. Well, that's a 0. So we know y equals 0. So we know we're going to have a horizontal asymptote at 0. Again, you could also remember that if it's x over x squared, you can't have that, so we know it's 0. Then we're also going to take, and we canceled something out, so we know we have a hole. That hole occurs at x minus 1. Solve it and I get x equals 1. But I need the other part. I need to know 1 and what other point, so I have to plug it in. So I get 1 over 1 plus 1. So that's 1 over 2. So I know I have a hole at 1, 1/2. So at 1, 1/2, I draw a circle. So I know what quadrant it falls in now. And I'm actually going to take it. I can also figure out, no, I'm just going to take it and I'm going to graph it the way it is. Again, once you start knowing some of your parts, you can take it. Remember, you don't draw through the circle. You go around the circle. And then you're going to draw your other one over on this side. Nice and easy. All right, so now we're going to move on to polynomial inequalities, and we're going to kind of baby step our way into them. They're not that difficult. They're actually pretty easy, especially because we already know inequalities, and we just need to pay attention to whether or not it's saying greater than or less than. All right, so we're going to graph the polynomials. It says in your graphing utility. I'm going to show you how to do it that way. I'm also going to show you how to do it by hand. All right, it says using your graphing utility, solve the corresponding inequality, and we're going to write the solution in interval notation. Well, remember, interval notation is when we have our parentheses, our brackets, our parentheses and brackets, all that good jazz. You need to remember if it's less than or greater than, you're going to use brackets or parentheses. If it is equal to, you will use brackets. Please remember that as we go through this process. All right, so we're going to graph it first. We're going to take and go into our calculator. We're going to go into y equals, and we're going to put in x minus 1. So x minus 1. And it wants us to actually take a look at the graph, so we're going to. It's a nice straight line. Now, the most important feature that we're going to look at is we want to know, where is x minus 1 greater than 0? Well, if you think of it on a number line, right? If we have our number line and we have 0 in the middle, we're looking for where everything is above 0, meaning we're looking for where is it positive? Where is all of my answers positive? So if I look at my graph, where does it cross the x-axis? Well, we're going to take a look. We actually cross the x-axis at 0. Again, I'm going to show you where are my answers positive. I'm going to take a look, and I'm going to take and see at 0 it's negative. At 1, I now am at the answer 0, which technically is considered a positive answer. And then I keep getting positive answers after that. Remember, my answers are this side, my y1. So I want to know, where is it positive? Well, greater than 0, I know that I'm going to have, where is it not included? Well, I get a negative number at 0. And all of my answers after that are positive. So I know from 0 to infinity is my solution. So I know it gets complicated, but we're going to look at it a little further. We have x squared minus 4, and it's less than 0. We're looking for, where are all of my answers less than 0, meaning where are they below the x-axis, meaning where are they all negative answers, right? So we're going to plug it in. We're going to look at y equals. We have x squared minus 4. I'm going to take a look at my graph. Okay, if I look at my graph, I'm looking for, where are the positive answers, meaning the negative answers. Where is it negative below the x-axis? So I need to know, it looks like it lands on the x-axis at -2 and 2, which makes sense, because if we were to factor this, we would get x minus 2, x plus 2. So we know that the x values are at a 2 and a -2. Okay, so we know that those are going to be our values that we're going to look at. So where are the answers negative? Well, between the numbers -2 and 2, it falls below the x-axis. But we're still going to use proper interval notation, -2 to 2. It is not going to be bracketed because we're looking at less than 0. Now look at C. Okay, we're looking, where is my polynomial greater than or equal to 0, meaning where are my answers positive? Okay, where are my answers positive? Or meaning, that's a typo, not below. Where are they above my x-axis? So let's take it, we're going to plug it in. We're going to look at our graph. We have x squared minus 6x minus 7. We're going to take a look at our graph. Okay, so I have two sides of my graph that happen above the x-axis. I need to know what those numbers are on the x-axis. So I need to know, what are the factors. If I look at my table really quickly, I see I have a factor at -1, and I have another one at 7. So I know I have from -1. Actually, you know what? I'm going to show you a different way. I don't like this method. Let's look at it this way. Draw your x-axis. So what we're going to do is this side is to -infinity, this side is to +infinity. We're looking for where are the answers positive, right? So we need to know our factors first. So what times what gives me a -7 but adds to be a -6? Well, it has to be X minus 6, no, X plus 7 and X minus 1. So X equals -7, positive 1. Did I do that right? Nope, I didn't right. Sometimes I make mistakes. X minus 7, X plus 1. I know X equals 7, X equals -1. All right, I have my X-axis. I'm going to draw my point at -1. I'm going to do another one over here at 7. And I want to know, I'm going to look at my graph. All right, again, I'm going to look at my graph and I'm going to go, okay, well, from -1 to infinity, it's positive. Between -1 and 7, it's actually below the x-axis, so it's negative. And from 7 to infinity, it's above the x-axis, so it's positive. All my answers are going to be positive. So I said, where are they greater than or equal to 0? Meaning, where are they positive? Well, if I do my interval notation from -infinity to -1, I'm going to use a bracket because I had a less than or sorry, I had a greater than or equal to. So I use a bracket. Because I have 2 of them, I know it's going to be a union. Again, I use a bracket because it's greater than or equal to from 7 to positive infinity. We're going to do another one for practice, okay? I have x cubed minus 1. I want to know, where is it less than or equal to 0? Meaning, where are my answers negative? So again, I'm going to draw my x-axis, my negative infinity side, my positive infinity side. I know I'm going to have 3 of these. Okay, so I actually need to know, I'm going to look at my graph and I'm going to plug it in. All right, so I have x raised to the power of 3 minus 1. Let's take a look at it on the graph. Where does it cross the x-axis? Well, it crosses at 1, so I'm going to put my 1 right here. All my answers to the left of that 1 are negative. All my answers to the right of that 1 on the x-axis is positive. Again, I'm looking for where are the answers less than or equal to 0. So where are they negative? Well, in the interval from -infinity to 1, I will use a bracket because it is less than or equal to. I prefer using this version of a number line to look at my answers versus trying to visualize it, and I don't like that way. So let's move on.